So what will we be covering? So we're going to approach an engineering challenge together. I'm going to kind of walk you through how I would take a look at the situation, see if you can kind of learn something from that, how to identify challenges and solve them, things like what kind of wheels are best, what's the best way to use the wheels, like do we want suspension, do we want paint treads, that kind of thing. Why is it important to make everything reliable? That's really important. How to use the parts properly, right? You don't want to misalign holes and try to bend screws, pins, stuff to fit. And why is it important to make a rigid robot? And lastly, design before you build. So let's begin. So how should you approach a challenge, right? You want to identify the problems. So I'll show you an example here, but you want to look at what problems might happen, not only now, but like in the future of your building. So you want to come up with solutions to it, research, look at all the other robot designs. It's okay to learn from other people. And then you want to prototype. Never stop prototyping. You're always going to learn from your mistakes, so make sure you do that. You're going to test that prototype, and then you're going to restart the process. It never ends, right? You can always improve. It never ends. So we're going to take a look at this field, right? What are some of the first challenges that come to your mind? You can just raise your hand. What challenges do you see for the robot on the field? Is it the barriers, the blocks? Go ahead.
I always think barriers, because
Exactly. I would agree. So that's what I selected there, right? So when we see that, we want to ask ourselves, well, what kind of wheels do we need? I'm sure that's kind of what you asked yourself as well when you saw the kickoff, right? What do we want to use? We want to use Omni wheels, or we want to use Mechanism, some stealth wheels, paint treads, right? All of those seem like viable options, right? So what are some of their pros and cons? Who wants to go for it? Which one do you want to advocate for?
I mean, okay, so the Omni wheels don't have very much traction.
Exactly, traction. Okay.
That's the big thing when you go over the barrier.
Okay.
Yeah,
Go ahead.
the stealth wheels can't strafe.
Exactly. Versatility, right? Really important with this year's game. You want to be fast and speedy, right? It's important to have versatility. Go ahead, Cody.
The Mechanism wheels can strafe.
Yeah.
That's what I was going to add.
Exactly. Right? Who knows what the problem with the tank treads is? Go ahead, Sebastian.
You can't tone while driving, you have to be stealth.
Right. And the other thing is speed. It's kind of hard to move that really quickly. Although it does help you get over the barrier quickly, right? Compared to the Mechanism wheels and some of these solid wheels, it's a little bit harder, right? We're going to explore that. So how do we want to implement them? This one's kind of hard to see. But do we use 4 wheels just kind of set up in line like a normal robot? Or do we want to add suspension? Or do you want to use a rocker drive, which is basically where you have, I don't know if you can see this, but there's a Mechanism wheel and an Omni wheel, and these kind of like, they swing, they rock, right? So they rock over the barrier, and that's how they get through, right? So these are all viable options. The question is, which one do we choose, right? That's that prototype phase, that's the design phase, all of that needs to be taken into consideration. So in terms of the drivetrain, this is kind of a, not a lot of people like to do this, but I think it's really important. So supporting wheels on both sides is huge, okay? The reason why is because when you put a motor on, sometimes it'll flex, right? Because all the weight is being pushed in the center, and your wheels will kind of come out this way, if that makes sense, right? So this goes along with Murphy's Law, which is what can go wrong will go wrong, right? Something might break during competition. You need to make sure the robot won't, right? You want to put every possible thing into it to make it not do that, right? Here, this is an example of where these motors might flex in, right? So we want to avoid that by trying to support on both sides, right? This doesn't only apply to wheels. Arms, servo contraptions, whatever you want to support on both sides, okay? All right, we're going to go into some more general tips about engineering. So use parts properly, right? If you have a channel here and a channel here, don't bend the axle to try to fit into both, right? Solve the problem. Because even if it takes you more time to fix things now, in the future it will save you time because that axle might break, it might bend, it might cause problems, right? So solve it now so you save your time in the future. Here you can see this is a large arm, right? It looks kind of heavy, right? So here they're only using one motor, right? But if you wanted to lift a heavy arm, you might want to kind of lower, like use a chain, right, to make it a bigger gear ratio, or use just a more powerful motor, right? You don't want to overheat the motor and cause it to not work anymore, because that's going to take you more time to replace it. So it's all about structure, right? This is Guten Freeze robot back from Skyson. It's a really good team. Okay, but notice how they're using this to use structure, right? They're putting cross beams all across here. Because if they don't, right, this is a giant arm, it's gonna start wobbling, right? And you don't want that, so it'll cause inconsistencies while you're scoring. So, I'm gonna ask this question to all of you. What do you guys think is the strongest shape in engineering? Go ahead. Hey,
I would say a triangle or hexagon.
triangle or hexagon? Okay, what do you think?
Triangle.
Okay, anyone else? Alright, so I would agree. I think the triangle is probably the strongest, right? And it's because of this physics thing, right? It's the weight and the force is being, directed across all the sides, right? Now, some shapes are stronger, such as circles, hexagons, right? But they're harder to manufacture, like when you're 3D printing and stuff, right? So this is one of our future mechanisms. It's an arm for our robot. But notice the shapes that the holes are made out of, right? This is done to save weight, but notice they are triangles. That's the strongest shape, right? We don't want to lose strength by picking up holes. So this goes with design before you build, okay? Notice how cool that robot looks, right? Can you do that if you're just free building just in real life? You can't really do like renderings and make it look really flashy for the judges, right? So that's why I say like design before you build something, even if it's on paper, even if it's in a CAD program if you're not the 3D model. Do it beforehand because it will save you time later. You'll work through all your problems first, and then you can build and you'll have a lot less problems, right? Now, I have another tip here. So keep things modular. You see how this is an intake and it comes off like that? These intakes can just be attached with a few screws, right, to the robot. So what that allows people to do is the team can build the robot and then they can attach the intake afterwards. So now not all people are working on the same thing at a time. You now can divide up the work. So now things get done faster and more efficiently, right? So how else can designing first be helpful? Okay, I don't know if you guys remember, but this used to be our robot. A lot of thought went into the design of it in terms of the drivetrain. So not only is it impressive to the judges just to design your robot, show them cool, flashy renderings, right? It shows that you're putting thought into it. And it's also impressive if you can even use physics to back up everything you do. For example here, we designed this flat plate, right? Nothing too extensive. We did a force analysis on it in design using Fusion 360, which is a design program. Now if you did it on paper, if you just pre-built it, you couldn't do that, right? We were able to do it because we designed it first, and then notice how the pattern followed where the blue is, right? The blue is where there isn't a lot of force. Notice where the holes are, there's yellow and green, because there's a lot of force there. So we structured everything so that we're not being in the way of where the force will be, so we're not like decreasing strength. So that's pretty much it. I'll have some cool resources here. GameManual0.org is really helpful for programming, designing, all sorts of stuff, even engineering notebook stuff. And then this is the Discord server for the First Tech Challenge sites for all across the world FTC teams to talk to each other. We can learn from other people's mistakes, right? And overall, just get some help building your own robot. So just thanks for listening, and does anyone have any questions? All right.
Quick
That's
pause.
all. I'll pass it on to Brian.